Welcome to this explainer. Today, we are officially kicking off day one of our AI literacy journey. And our goal is simple: completely demystify all those AI buzzwords you keep hearing. We're going to build a rock-solid understanding of how these technologies actually fit together, and we're going to do it without getting bogged down in confusing technical jargon. To make sense of it all, we'll be using a simple, nested circle mental model. By the time we wrap up, you'll have a crystal clear picture of what these systems really are and exactly how they operate.
All right, let's take a quick look at our agenda. We've structured this explainer kind of like a Matryoshka doll. We'll start with number 1, the big umbrella of AI. Then we step into number 2, the inner circle, machine learning. From there, we go deeper with number 3, deep learning. And finally hit number 4, the brain, neural networks. Then we zoom back out for number 5 to look at real-world AI applications and wrap things up with number 6, why this matters today.
Okay, let's start right at the top with section 1, the big umbrella, AI.
So, when people casually throw around the term AI, they're usually just referring to this broad umbrella category. At its core, artificial intelligence simply refers to any machine or system designed to mimic human cognitive functions. The ultimate goal here is to optimize those really complex tasks that humans have historically done ourselves. Think problem solving, making decisions, or translating languages. It's the big parent category for literally everything else we're going to discuss today.
Think about how huge a shift this is in how we build tech. Unlike classic software that blindly follows static, rigid rules, where a programmer literally has to code, if X happens, do Y. An AI system acts a whole lot more like a smart thermostat in your house. It doesn't just run on some fixed dumb timer. It actually learns your household's routine over time to dynamically optimize energy usage while keeping you comfortable. It adapts.
Now, understanding that an AI adapts is one thing. But it brings up a pretty fascinating question. How exactly does a machine move from just following strict instructions to actually learning from its environment? How does it figure out that routine?
Let's step inside our first nested circle to find out. Welcome to section 2, the inner circle, machine learning. Machine learning is a specific subset of AI. This is where human experts step in to help a computer system identify patterns. By feeding the system lots of data, the machine learns to make highly accurate predictions and minimize guessing errors. It's really not magic, you know. It's just observing historical patterns so it can guess what's going to happen next with incredible accuracy.
Honestly, think of this process exactly like baking a cake. First, you input your specific ingredients, which in the tech world is your historical data. Second, the algorithm mixes them together in a certain way to identify relationships and patterns. And third, it outputs a final dish, which is the machine's prediction. The better your ingredients, the better the final dish. It's that simple. But here's where things get kind of tricky. There's this massive risk called overfitting. Imagine a child learning to identify chairs just by looking at pictures. If the training data you give them only consists of blue chairs, well, the child incorrectly learns a flawed pattern. They're going to predict that absolutely all chairs must be blue. This perfectly highlights that if your training data is skewed or incomplete, your machine learning model will make totally flawed predictions too. So the crucial point here is that classic machine learning relies heavily on human experts to carefully label and structure that training data. But what happens when we have massive amounts of raw, unstructured data? We're talking millions of unlabeled photos or mountains of raw text documents. Human labeling literally becomes impossible. Which brings us perfectly to section 3, our next nested layer down, going deeper, deep learning. Deep learning is a highly scalable subfield of machine learning, and its absolute superpower is that it can ingest raw, unstructured data, like text or images, and figure out the distinguishing features entirely on its own. It automates the feature extraction process. That means it doesn't need a human jumping in to tell it what to look for.
Let's put them head to head. If you want to train a system to recognize fast food, classic machine learning needs a human expert to label specific features. Someone has to sit there and point out, hey, a burger has a bun, a patty, and lettuce. Deep learning, on the other hand, can just look at thousands of raw images and automatically figure out what makes a burger, all by itself.
The way the deep learning process actually manages this is a bit like peeling an onion. As data passes through the system, the outermost layers spot very simple, raw features, like straight lines or edges. The middle layers combine those lines to see textures and shapes. And finally, the deepest layers synthesize all of that together to recognize a complex object, like an entire face or a dog's ears.
So what's actually under the hood doing this? Let's move to our final, innermost circle, Section 4. The brain, neural networks.
Neural networks are the structural backbone making deep learning possible, and they get their name because they quite literally mimic the way interconnected biological neurons communicate electrical signals in a human brain. It is essentially a mathematical recreation of how we process information.
If we map out the basic anatomy, the network consists of an input layer where the data enters, an output layer where the prediction comes out, and multiple hidden layers in between. Actually, fun fact, if a network has more than 3 of these hidden layers, that's what officially makes it deep learning. And inside these layers are artificial neurons, which we call nodes, connected by synapses.
You can think of each individual node as a tiny mathematical gatekeeper. When it receives messy, raw data from the layer before it, it multiplies that signal by an importance factor, called a weight, adds an offset bias, and runs it through an activation function. What does that mean in plain English? It just normalizes messy data into a clean, standardized number between 0 and 1 before passing it forward. It brings order to chaos.
But what happens when the network makes a mistake and gets the prediction wrong? Well, it uses a brilliant mathematical process called backpropagation. The system calculates the error and adjusts its internal weights backward through the layers. It learns exactly like a child touching a hot stove. It registers the pain of the mistake, adapts its internal logic, and learns to avoid making that exact same error the next time around.
Okay, let's step back out of all that microscopic mathematical machinery for Section 5, real-world AI applications.
Because the truth is, we interact with these nested technologies literally every single day. Every time a social media app recognizes objects in your photos, or virtual assistants like Siri and Alexa process your natural language, you are looking at deep learning at work. When Amazon analyzes your past purchases to recommend new products, or when enterprise logistics systems optimize delivery routes, they are all relying on the exact systems we just mapped out together.
Finally, let's wrap up with Section 6, why this matters today.
As this quote perfectly emphasizes, understanding AI shouldn't require a PhD in data science. By having this structured, nested mental model from the broad AI umbrella all the way down to the neural network nodes, we empower non-technical leaders to ask the right questions. You can calibrate your trust correctly, spot potential flaws in data, and confidently implement AI safely in your business.
So, as we conclude this explainer, I want to leave you with one final provocative question. Since we now know beyond the shadow of a doubt that these machine learning systems rely entirely on data to learn and adapt, you have to ask yourself, are you treating your data like raw, unrefined crude oil that needs strategic processing to actually become valuable, or are you just wandering blindly collecting noise? Refining your data is absolutely the only way to truly fuel the engines of tomorrow. Thanks so much for joining me on this explainer, and keep learning.